write the equation of a line tangent to x squared plus y squared equals 13 at negative 3, 2. So negative 3, 2, that's the point we're looking at. The circle is defined by x squared plus y squared equals 13. That means that 13 is the radius squared. So if we want to know what the radius is, it's not 13, it's the square root of 13. Square root of 13 is about 3.6. So let's just fill that in here just to get a picture. And so we have something that looks kind of like this. And then we have some line tangent to that point. And so if you don't remember what a tangent line is, it's a line that just touches the circle at that one point. So it does not touch the circle anywhere else. It just comes in like this, touches that point, and then keeps going. We want to know the equation of that line. Well, there's a property of circles that you may or may not remember from geometry, and that is that if you look at a radius and a tangent line at the point where that radius meets the circle, those will always be perpendicular to each other. So if we can find the slope of that radius, then we take the opposite reciprocal. That will tell us the slope of the line. So the slope of the radius, well, the rise is negative 2. The run is 3. So this is negative 2 over 3, which I guess we can't reduce that. So the slope is negative 2 over 3. Let's take the opposite reciprocal of that. That's going to be positive 3 over 2. So that will be the slope of the tangent line. Well, now we have a point and we have a slope, so let's use point-slope form. Plug in what we know. We know the y value is 2. 2 equals, the slope is 3 halves, and then x minus negative 3. Well, subtracting negative 3, that's the same as adding 3. And so we have the equation right there. And again, if you want to put that in slope-intercept form, you're welcome to. Well, we can leave it just like that. Graphing inequalities, there's a few things we're going to need to remember about this. So first of all, we need to remember what the difference between a strict inequality and one of the or equal to things. So if we have something that looks like this with a strictly less than, then when we draw our line, it's going to be a dotted line. When we have greater than or equal to or less than or equal to, one of the or equal to's, we want a solid line because we want to include the things on that line. So in the first one, the first example, example 4, we have strictly less than, so we're showing the boundary to this. But we're not including that. That's why we use a dotted line. It shows the boundary without actually including it. With the or equal to, we want to include that, so we fill in the line. All right. So let's look at the first equation here. X squared plus y squared is less than 9. So we got to think about what the radius of this circle is. Well, the equation is x squared plus y squared equals the radius squared. So if 9 is the radius squared, then 3 is the radius. So let's just put some points here, all equidistant from the center with a radius of 3. And then we're going to have a dotted line here because it says strictly less than. And now we need to think about where we shade. So I want you to pause the video now and think about where it is that you're going to shade. Once you figure it out, or once you think you have an answer, go ahead and replay the video, and I'll talk about it in just a moment. Okay, so we need to think about what this inequality is telling us. It's saying that the radius squared is bigger. I mean, the radius squared, we can essentially just talk about it as the radius. So the radius, the x squared plus y squared has to be less than the radius. So we need smaller things. We need things inside the triangle. I'm sorry, inside the circle. Another way to think of this, we can use that point test. Let's pick, say, 0, 0, and let's see if that makes it true. So we could say, 0 squared plus 0 squared is less than 9. Well, that's 0 is less than 9. That is true. That means we're going to shade inside the circle. We could even try this a different way. Say we take something outside the circle. How about the point 4, 5? That's outside the circle. If we do 4 squared plus 5 squared, less than 9, 4 squared is 16. Oh my goodness, come on. Okay, 4 squared is 16. 5 squared is 25. We say is less than, oh my goodness, okay, less than 9. Well, 16 plus 25 is definitely not less than 9. It's definitely bigger than 9. So that's false. It's not going to be that. We'll cross that out. So we have to shade inside. Example 5. X squared plus y squared is greater than or equal to 20. So first, you may think, oh, 20, that means it's going to be off the graph. But remember, 20 is not the radius. It's the square root of 20 that's the radius, which is about 4.5 approximately. So let's put some points at 4.5, a distance of 4.5 from the center. And in this case, it's greater than or equal to, so it's going to be a solid line. And then we want greater than. So if we think about, say, putting in the point 0, 0 again, we get 0 squared plus 0 squared is greater than or equal to 20, which says that 0 is greater than or equal to 20. Oops, equal to 20, not 0. That is not true. That's false. So we do not shade the part with 0, 0. We shade everything else. Or another way of looking at that is that the x squared plus y squared, if we build that triangle, say we have some point, and we do that right triangle, then the x squared plus the y squared is going to have to be bigger than the radius. So this would be the radius here, this point. And so the x squared plus y squared, that's going to have to be longer than that radius squared. And now you should be able to finish up the homework, do those last few problems, 32, 45, 44, 45, and 53.